Welcome to Beyond the System with Dave and Josh.
Hey, welcome back, everybody, to Beyond the System. And today we're going to take a very deep dive into the heart of the refrigeration system, the compressor, right, Josh?
Absolutely, Dave. One of the most critical components in the system, the heart of the system, you may say. Something that if it doesn't get appreciated, it's going to let you know.
Absolutely, 100%. And the good news about a compressor, though, is that it's one of the components that can be maintained, and if maintained, may outlast your plant itself. Is that correct?
May outlast your plant and your employment.
That's right. So before we get going, let's start simple, Josh. Before we get into this deep dive, what role does a compressor play?
So the compressor is basically the heart of the system. It takes low pressure vapor off of the evaporator. It increases the pressure, it sends it to the condenser. And the reason why it's so critical is that we need the pressure increased to increase the temperature so that we can reject the heat that we're absorbing in the evaporator. Aside from increasing the pressure, it also keeps the flow of the refrigerant moving through the system from the high side to the low side, and basically creates our continuous loop through the refrigeration cycle.
Okay, and really there's different types. Like there's your reciprocating, your screw. What other sort of compressors do we have that we would look at in a refrigeration system?
Yeah, I mean, on some of the smaller, maybe mechanical dehumidifiers, you might get what they call a scroll compressor. On some of the large air conditioning applications, you would see a centrifugal compressor. In our business, our industry, HVAC, refrigeration, you're going to see a lot of small HVAC compressors, be either the scroll or the reciprocating machine, but they would be a hermetic machine, meaning they're mechanically sealed and they typically can't be serviced. That's why if your dehumidifier compressor fails, you typically see mechanics coming in and re-enringing the compressor with the new one. There's really no saving those. But on the more industrial application, you're going to probably see big screw compressors just based on the sheer volume of work they can do in a smaller footprint than a reciprocating machine. And then in ice rinks, you're going to see a variety of screws and recips, more of the mini screw type compressor or the reciprocating compressor. I would say probably majority of ice rinks, you're going to see reciprocating machines.
Makes sense. And they're like essentially just like a pump, right? I mean, you're talking about earlier about high pressure and, increasing pressures and heat, et cetera. But really, they're just pumping the refrigerant throughout the refrigerant cycle, correct?
Yeah, they're pumping refrigerant vapor. One thing that has to be known, you cannot compress liquid. So that's why we have heat exchangers with vessels above them. Those vessels, they allow for separation from liquid and vapor, and they provide the protection to the compressor. Without it, you have to critically control your refrigerant flow through, say, a direct expansion type loop, which can put the compressor at risk, especially bigger compressors. They require superheat to protect them. The superheat ensures there's no liquid left in the vapor stream. And when we're talking about ice rink application or industrial refrigeration, often the band is so tight. We don't carry a lot of superheat over to the compressor, often zero, and we need those vessels there to protect from any liquid getting into the compressor. So, it's basically, as you mentioned, a pump for the system in the most simple terms, but very critical.
Yeah, it's a bit different than some of the other components in the system where, like, let's say, for example, like a condenser or heat exchanger, as it's starting to lose efficiency or as maybe it just works harder. But the compressor, that's not quite the case, is it?
Well, I mean, I would say that depending on how well maintained the compressor is, it will always have a limit to how hard it can work. I think from a working harder perspective, it means it's working longer. It's going to take longer to do its job because, the clearances inside these compressors around either the piston rings or, say, the